According to Ben Goertzel, Hyperon could be a decentralized open AGI in 3 to 10 years. And large language models, such as ChatGPT, could be a small part of it. But what is Hyperon and how does it work? To understand that, I read through a 100-page paper, so you don't have to. Let's jump right into it. What the paper describes is OpenCog Hyperon, a cognitive architecture and AI system design that we believe possesses the breadth and complexity to achieve AGI at the human level and beyond via a combination of autonomous learning and human education and supervision. But what does intelligence mean in the context of AGI and this paper? There have been a variety of different attempts to define intelligence in the past years and decades, but still we cannot clearly pinpoint it. But we need a shared understanding so we know what we are talking about here. The paper puts it like this. In the context of Weaver's concept of open-ended intelligence, achieving a goal is not the crux of intelligence, rather the focus is on self-organizing aspects. Hyperon is intended as a system that can achieve complex goals in complex environments, including goals that it represents explicitly as well as goals that arise implicitly, due to its self-organizing dynamics. It is also intended as an open-ended intelligence that, as it pursues its self-organization and its agency, ongoingly pursues both individuation and self-transcendence. So I don't know about you, but that sounds like a definition of an intelligent system that I can get on board with. Especially the pursuit of its own intrinsic goals sounds like something that any intelligent being definitely should be able to do. Now, when it comes to building this intelligence, scale might be an important factor, especially when we consider the human brain's sheer size with hundreds of billions of neurons. So OpenCog intends to use the potential of the internet, which is great for scaling. For example, AGI systems living on decentralized compute networks could serve as a cognitive hub of a centralized global brain. Now here the paper is talking about a centralized brain, but it moves on to one of my favorite aspects about Hyperon, which is decentralization. And according to the paper, Ben Goertzel has been thinking for a long time about the need for decentralized control of the distributed AI processes, comprising a large-scale AGI, and the importance of this for keeping early-stage AGIs out of the hands of centralized entities with narrow goals. And in my opinion, this is absolutely key. Or does anyone here really want to have a centralized entity such as Microsoft, Google, OpenAI, the American government, or whoever it is in full control of the emerging AGI, basically being able to outsmart and control everything? Oh, this isn't going to end well. But for now, the paper goes on and talks about cognitive synergy, which stems from an understanding of how different types of memory and learning mechanisms in the human brain interact. Cognitive synergy highlighted how the brain translates a problem from one kind of memory to another kind when it gets stuck, essentially employing different kinds of learning mechanisms. And as for my understanding, the concept of cognitive synergy leads to the core foundation of which Hyperon is built on, which the paper gets into now. But first, I have to admit that it's definitely a little bit too technical for me at some places. And I really took a while to understand this with the help of Claude 2 and reading through it multiple times. So I will explain everything to the best of my understanding and give you hopefully simple analogies and concepts for what the paper is talking about. But I cannot promise that I understood everything 100% right. If you want to read the paper yourself, it's down in the description. But going on, the paper states, the core construct of Hyperon is the atom space, a metagraph comprised of nodes and links with complex interlinkage structures. This metagraph is highly versatile and allows for labeling nodes and links with various kinds of data, including subgraphs. This labeling mechanism can also facilitate the embedding of complex type systems in the metagraph. Alright, if you don't have any coding, AI or whatever background, just like me, you probably right now ask yourself, what the hell is the paper talking about here? Well, that's definitely what I asked myself. So let's explain that as simple as possible. The core foundation of Hyperon is the atom space or metagraph. You can basically think about that as the brain of Hyperon at this point. And now it's basically just described how data is connected. So let's say we have the node apple and the node fruit, and they would be connected via a link. The amazing thing about the metagraph is that you can link multiple different nodes together, make links to different links, and attach new data. So let's say we have our apple here, which is linked to fruit. And then we also have a node for color here, and this color node has the data red, which is not linked yet. But then Hyperon learns more about apples and attaches the node color with the data red to apples. And when Hyperon learns even more about apples, that apples can also be green, it attaches more data to the color node for apples. Alright, now that's at least how I understood it. Another very important piece that makes Hyperon qualitatively different from anything in earlier OpenCog versions is a programming language called Meta. Meta programs are sub-metagraphs in atom space and are interpretable as procedures for rewriting portions of atom space into modified or additional portions of atom space. By its basic nature, the meta interpreter enables atom space to undergo a metamorphosis and initiate self-rewriting. Okay, let me explain meta the way I understand it in consultation with Claude 2. As human beings, everything we do continuously over a longer period of time becomes habitualized as a simple way to conserve energy. That can be very simple things like brushing your teeth. It's very habitual. You probably have a huge need to brush your teeth in the evening and in the morning if you have done it for a long period of time, because it's a habit now. That also goes for things like negative self-talk. That also becomes habitualized if you do it for a long period of time. But we don't want to get there now. For now, it's just important to understand that everything we do as human beings over a long period of time becomes habitualized as a way to conserve energy. Meta now, as per my understanding, helps Hyperon to habitualize certain processes. For example, labeling fruits with a color. Instead of being a one-time process that Hyperon does, thanks to Meta, this process becomes automized and thus way more efficient. On top of that, Meta can rewrite certain habits if they are inefficient or more efficient ways to do things have been found. The paper goes very in depth to explain Meta more, as it states here on page 18. Meta is a novel language, and getting used to it requires letting go of some traditional ways of thinking about programming and acquisition of some new habits. For readers who have sufficient technical background, it seems a brief summary of highlights and different aspects may still be of some value. And I am definitely not a person with a sufficient technical background. If you are, the paper is down in the description, but I'll move on and leave it at that. The paper now goes on to talk about LLMs, such as ChatGPT, and their limitations when it comes to AGI, and compares them with Hyperon's approach. As the paper states, there are some quite serious limitations to LLMs. For instance, systematic multi-step reasoning as required in scientific research or producing groundbreaking mathematical theorems is challenging for these systems. This is partially because they predominantly recycle existing knowledge rather than extending far beyond it. Additionally, LLMs struggle with creativity, often producing work that is derivative rather than is aesthetically rich or moving, let alone artistically groundbreaking. Ben Goertzel talked about these limitations in another paper that I've dissected in a video right over here. Or maybe over here. Researchers and scientists are split when it comes to AGI, and the paper states that Gary Marcus and Jan LeCun, for instance, view LLMs as a diversion from the path to AGI, while others think of them as significant progress, believing that scaling up and augmenting current LLMs or combining LLMs with other technologies could be a viable path to human-level AGI. Ben Goertzel and his colleagues are probably in the first camp and don't believe that LLMs by themselves will lead to AGI. But that doesn't mean that LLMs will not play an important role on the way to AGI, as the paper states. Our current working hypothesis is that LLMs may be tightly or loosely integrated with Hyperon systems, and in this way could come to play a significant role in Hyperon-based general intelligence. And the paper talks more about how this integration could look like later on. Now, to develop AGI, the Hyperon-based approach supposes learning explicit representations of real-world situations, which brings two main challenges. Scaling knowledge metagraphs at least to the amount of information digested by LLMs, mitigating the brittleness sometimes found in symbolic AI methods, which sometimes comes together with the dependence on handcrafted representations, rules, and algorithms. This basically means that the symbolic nature of the metagraph, Hyperon's brain if you remember, often comes with the challenge of understanding things in a real human-like way, and often things need to be handcrafted for it. In order to discuss possible solutions, the paper moves on to talk about Hyperon structure further. If you remember, we have the atom space, which is basically Hyperon's brain, but there can be multiple atom spaces within Hyperon, and each serves a different function. For example, there's a distributed atom space, DAS, that can run across multiple machines. From my understanding, the DAS is incredibly important, and if we go back to our brain analogy, the DAS basically serves as a corpus callosum. So if we look at the brain, it has two hemispheres, the left hemisphere and the right hemisphere. And these two hemispheres are interconnected and talk with each other via the corpus callosum, which is the interlinkage structure between both hemispheres. The DAS is the source of knowledge and the container of any computational result that might be created or achieved during the execution. So basically, if one atom space needs information, it talks to the DAS, and the DAS connects that atom space with another atom space that contains the necessary information, so both can talk with one another. I hope that makes sense. Good. When it comes to multiple possible atom spaces, you could wrap a large language model or other deep neural networks in an atom space API and perform pattern matching against them. The neural lobes could interconnect directly and or use other spaces such as a DAS default atom space as a hub. Now this is where LLMs come in. They could be basically one part connected to multiple different atom spaces with the DAS as a central hub. Now this slowly starts to look a lot like an actual brain to me. And now my favorite part about Hyperon comes in again, decentralization, which could potentially open up a lot of computing resources. Through appropriate blockchain integration, a distributed Hyperon instance can be spread across many machines worldwide, without need for a single owner or central controller. One can have coordination among many agents, running on different machines without requiring complete trust between the parties involved. A decentralized open source AGI on a blockchain sounds like something I can get behind. And also sounds exactly like the path we should take if we don't want the development of AGI end in a complete disaster. Of course, these are just my words, but let's be honest here. Can you really imagine one single entity having full control over AGI and everything that comes along with that? Or as the paper states, the use of decentralized infrastructure also decreases the odds of any single party achieving autocratic power over powerful AGI systems. And to avoid that, Hyperon could be integrated with SingularityNet, amongst other decentralized tools. As the paper states, at its core, the SingularityNet platform is a distribution channel for AI services that allows any developer of any sort of AI method to monetize API calls in a trustless setting. Hyperon will be offered on the platform with a number of AI strategies and functionalities deeply integrated, such as LLM, ECAN, PLN, and Sister. There will, however, be opportunities to integrate a wider variety of services into the Hyperon framework. The decentralized platform offers this opportunity to every developer or organization that would like to take part in extending the capabilities of Hyperon. This sounds fantastic to me and seems to open up incredible potential and opportunities for the further development of decentralized AGI. The integration of Hyperon with SingularityNet will enable the global community of developers to contribute and enhance its core capabilities, and similarly enabling anyone to connect and benefit from its growing potential. Again, I'm not the most tech-savvy person, but this makes me incredibly excited about the further development of Hyperon. And the decentralized nature, for me, in my opinion, makes this the most important AGI project. This decentralized nature and the possibility to integrate multiple different atom spaces makes Hyperon very unique, as the paper states on page 43. Hyperon is a platform precisely for AGI research and development, with a focus on cognitive synergy between different paradigms, approaches, techniques. This makes Hyperon different from other proto-AGI systems, which are typically built around one particular theory. Hyperon allows incremental development of multiple paradigmatic, interoperable components with strong both symbolic and neural parts. So as from my understanding, Hyperon makes it possible to create a synergized system of LLMs and whatever other approaches to AGI are out there, helping them to all work with one another. The paper goes on to summarize the key components involved in carrying out human-level general intelligence functions according to the Cog-Prime cognitive model. I'll just give a brief overview of the different figures here, just in case you want to pause and look deeper into them. High-level mind architecture. Action and reinforcement subsystem. Language subsystem. Perception action subsystem. Figure 10, a subsystem that has no proper name. Perceptual subsystem. Alright, that's just as an overview. Now, as the paper states, the various cognitive processes work together rather than against each other, so that, e.g., when one of them gets stuck in carrying something out, it can translate its intermediate state into the native languages of other cognitive processes and ask them for help. Which is basically how the human brain works as well. Information gets processed, and if it gets stuck, it gets forwarded to a different area of the brain. The paper now goes on to take a look at how the Hyperon cognition approach compares to the various components identified in the standard model of mind. I will now give an overview of the different components and just mention a few key aspects. Well, aspects that I think are key, for whatever that's worth. But let's now proceed through key components of the standard model, explaining how they are handled in the Hyperon Cog-Prime cognitive design. Episodic memory, working memory, procedural memory, reasoning, which is something where the paper goes really in depth. And this is an aspect where LLMs could be very useful as well. As the paper states, LLMs are good at the common sense reasoning part. PLN inference is good at the logical reasoning part. And our semantic parsing initiative, and that parsing English into logic, provides a viable path to syncing up common sense reasoning in LLMs with PLN reasoning. So PLNs are probabilistic logic networks and are based on logical rules. This is great to counterbalance LLMs, which have a huge database, but often lacks the real-world understanding and logic behind it. Moving on to further components. Reinforcement learning, language learning and usage, This is also something where LLMs can be very useful, as the paper states here. Overall, the fusion of deep learning techniques with symbolic structured reasoning, as exemplified by the Hyperon architecture, holds the promise of revolutionizing NLP. This integrated approach not only aligns well with the capabilities of modern LLMs, but also sets the stage for the development of NLP systems that understand and generate human language with unprecedented nuance, coherence, and contextual relevance. So basically, integrating LLMs with Hyperon would lead to a deep understanding of the language used, and not just a prediction of what is the most likely character that comes next, which is one of the core weaknesses that LLMs have. Just as a quick side note before we move on to remaining components, the paper offers solutions for all of these components when it comes to Hyperon. Some of them are already further developed than others, but for time's and simplicity's sake, I will not explain all of them in depth, but just give this quick overview. Please read the paper if you want a deeper understanding. Again, the link is in the description. But moving on to the remaining components of the standard model of mind. Multimodal perception, action learning and coordinated action, goal refinement and goal system management, reflexive self-understanding, modeling and understanding of other minds. From here, the paper moves on to consider a few core aspects of human mind that are not explicitly called out as key aspects of the standard model of mind, but are considered in the standard model in various ways, such as world modeling, emotion. When it comes to emotion, the approach is to give a way to supply AGI systems with rough analogs of standard human emotions, which will only sometimes be something one wants to do, depending on what kind of system one is building. Which sounds about right. You can imagine that you want certain AGI systems to have, for example, compassion, but you definitely don't want every AGI system to have analogs of every human emotion. Moving on with further aspects, creativity, consciousness, and the paper immediately moves on and states that consciousness is a massively overloaded term and can mean numerous things. So that being said, consciousness is a massive can of worms that we don't necessarily want to open here. Or as the paper states, from a practical perspective, however, there are so many unknowns here that the nitty-gritty work of building AGI systems tends to set aside questions of conscious experience and instead work in terms of neural and cognitive correlates of consciousness. Like this, the huge philosophical implications of consciousness doesn't need to be further discussed here, but instead we look at thinking and neural patterns that are similar to patterns in the human brain. The paper goes on to point out key differences between how Hyperon works and how the human brain works, and states the same non-human aspects of Hyperon are likely to be key to the transition of Hyperon from human level to radically superhuman general intelligence. The next paragraph is very interesting to me. Let me say briefly that I'm a hypnotist and I help people to work with their subconscious to resolve limiting beliefs, traumas, deeper subconscious wounds and things like that. What the paper describes here, Hyperon will be able to introspect and analyze over its whole knowledge base and use this understanding to explicitly revise all its knowledge and rewrite or redesign all its cognitive procedures. Sounds a little bit similar to what I help my clients to do. Throughout your life, and especially in your early childhood, limiting beliefs and possibly traumas are formed. These are stored in your subconscious, and what you do when you work with the subconscious, particularly with hypnosis, which is what I do, you go directly back to these experiences, you resolve them at their root, and then you install whatever other empowering belief or situation you want to have that serves you in a better way. And that sounds pretty similar to what Hyperon seems to be doing on an ongoing basis. Well, at least I thought this was very interesting and I wanted to point this out. By the way, if you thought this was very interesting as well, don't forget to leave a like. Or if you thought the rest of the paper was interesting, easy to understand, valuable, helpful, or just for the effort I made. Thank you a lot. Like, I know a like is just a small click for you, but it really means everything for me and the videos I make. But moving on, as the paper states further, we are all well aware that current pre-alpha Hyperon systems lack many aspects of general intelligence observed in ordinary one-year-old children. As most of Hyperon is yet to be developed and a lot of it is theoretical, let's have a look at the timeline. As you can see, the alpha version is supposed to come out in January. And I for one definitely want to start using Hyperon as soon as possible. Upon this release, we will begin a significant outreach initiative aimed at building a sizable active Hyperon developer community. So if you are a developer and you like the idea of decentralized AGI and not one entity having full control over the development of it, I highly recommend you to get involved. And if you are not a developer and just like me, this is what you will be able to use. To accompany the alpha release, we are working on a few practical demonstrations of the early Hyperon codebase as well. Some ideas under current consideration include a Minecraft playing assistant that is built on Hyperon and uses program synthesis. Addition of a rewritable active memory to large language models, which we currently use to control dialogue systems behind humanoid robots like Grace, Sophia, and Desdemona. A Hyperon-based framework for symbolic control of generative AI, particularly for image generation, enabling e.g. the flexible combination multiple stable diffusion models to generate novel structures. Use of PLN in the Rejuve project to replace the bias network currently used to estimate biological age based on various attributes of an individual. I am looking forward to the alpha and further development of Hyperon more than anything else in the AI space, because of already mentioned reasons. Of course, my channel is way too small to be sponsored by SingularityNet or anything like that, so I'm just talking out of my own beliefs and what I've seen here. And this seems to be humanity's chance to develop AGI in a way that is actually beneficial for all of us and not detrimental or maybe lead into catastrophe. So this is definitely where I will pay attention the most. What are your thoughts on that? Please let me know in the comments down below, especially if you have a better technical understanding than I have. Please let me know and let's talk about it. The paper closes with the statement, "It appears to us that we have an extraordinary opportunity in the next, let's say, 3 to 10 years to achieve human-level AGI." And I'm very excited to see more. Now, the fundamental aspect of how decentralization works with Hyperon is blockchain technology. And I made a dedicated video to explain blockchain technology and how it works, very easy and very simple to understand. You can check it out right over here. And in the future, I'll probably talk a lot more about blockchain, SingularityNet, and all of this.